Hello and welcome to our first video of the school year. It's Tuxedo T-shirt day because this is one of those skills that on first glance looks fancy, but when you get down into it, it's really not all that bad. So, today we're talking about the properties of multiplication. This is multiplication hacks. How can you use different ways that multiplication works on math problems to kind of mess with them and make them easier for you to do? Because as I'm sure you've already noticed, 5th grade math gets real weird real quick. We get really big problems that are not all that hard if you know how to hack them correctly. So these properties, if there's one thing you're going to use for the whole rest of the school year and probably forever, these properties of multiplication are something you'll use in high school science classes, you'll use them in high school math classes, because they look pretty fancy, but they're not too awful bad. Our first property I want to talk about is the commutative property. So commutative property, and I'm walking away from the camera, which you're not supposed to do when you're recording, but we're going to do it anyway. It's right here. The commutative property means one thing. It's a facts family. And remember, whatever I put up here, you want to put in your notes, so that way you've got it with you all the time. You can always use it, even when we're done with this chapter. If you get a review question later on in the school year, and it talks about commutative property, you can just go, oh yeah, those bright yellow notes. Those are in my folder right here. Does anybody know what I mean by fact family? Remember, raise your hand, don't yell at me. Sir?
Like, you can add 8 and 3, and then you can multiply, and then you can do...
What do you get when you add 8 and 3?
Yeah.
You're dead on the money. You get 11. A fact family is, those numbers are related like a family. 8 plus 3 equals 11. But you can rearrange those numbers and take 11 minus 8, and you're still going to get 3, right? Mm-hmm. Or you could take 11 minus 3, and you're still going to get 8. Basically, what that means is, these numbers can shuffle. And you know, addition and subtraction are related, right?
Yeah.
Just like multiplication and division are related. Multiplication is taking groups and putting them together, and division is taking a lot of things and putting them into equal groups. So there's the same thing kind of flipped around. So we can use this commutative property as a fact family, and we could say something like 7 times 3 equals 21. Because 7 groups of 3 adds up to 21. All multiplication is that multiple addition. Just do it faster. So would it also be true, according to the commutative property, if we flip these pieces around, would we also be able to say 3 groups of 7 equals 21? Would that be true? Give me a thumbs up for yes. That's no thumbs down, by the way. Yes. 7 plus 7 plus 7 is 21, and 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3 is 21. It all works. That's it. That's commutative property. Commutative property just says you can move the pieces around, and they're still going to add up to the same amount of number. Last year we talked about apples in a bowl, right? If you have 7 groups of 3 apples and you put all those apples in a bowl, you get 21 apples. If you have 3 groups of 7 apples, you throw all those apples in a bowl, you get 21 apples. It does not really matter. Could we put in the notes here, moving pieces? Would that help us remember maybe? Maybe? That just means it doesn't really matter where the numbers go. You could even rearrange those into division, right? 21 divided by 7 is going to be 94, correct? 21 divided by 7. Remember, if this is a fact family and we're switching all these places around, if we have a 21 and a 7, because they're related, it has to be 3. So 21 divided by 7 has to be 3, doesn't it? Yeah. Unless we're waving a magic wand and changing numbers around. If we take those 21 apples and we split them up into 7 groups, it's automatically going to equal 3. Just because if these numbers are related, They have to work together like that. That one's a pretty easy one. We good? Most of these are pretty easy. We don't really think about them. They kind of exist in our head. We know, you guys, this is not new information. You knew this before. But this is a name for it, because if we don't have a name for it, I can't tell you, hey, we're going to use this. Because it'd be really hard for me to teach you later on down the road, hey, you know that thing where we flip the numbers around and then they stay the same? And you're like, no, I don't. You're being weird and I don't understand your words. But if I did say, hey, that commutative property, remember we can move the pieces around, you'll go, oh yeah, I get that. So these are mostly things you already knew. It's just we kind of have to learn the name for them, otherwise we can't use them. Associative property. Looks a little stranger, not really all that bad. Associative property, I'm going to do the thing where I walk away from the camera again. Right here. I'm keeping them up here for you. Is a multiplication property where we're talking about grouping. If I have 2 times 5 times 2. What's 2 times 5?
10.
10. What's 10 times 2?
5.
That's 10 divided by 2. What's 10 times 2?
10.
10 times 2. That's 2 groups of 10. 20, right? Now, here's what associative property means. Associative property says because multiplication talks about groups of groups, we're always going to end up with the same number of things, no matter what. No matter if we divide it up with parentheses like this. 2 times 5. Because remember, we always do the work in the parentheses first when we have a problem like this. What's 2 times 5?
10.
Still 10. What's 10 times 2?
20.
Still 20. And even if I move the parentheses to another part of the problem, like that, what's 5 times 2?
10.
What's 2 times 10?
20.
The associative property said if you're working with groups, with multiplication, it doesn't really matter what order you multiply the groups in, you're always going to get to the same number of things. Your number of apples in the bowl is always going to be 20 apples. Doesn't matter what order you buy them in, doesn't matter what order you group them in. You can move this problem around, and as long as we're just using multiplication, we're good. Would you be able to use these two properties in addition too? As we said, addition is basically just, well, multiplication is basically just a more complicated version of addition. Give me a thumbs up if yes, thumbs down if no. Can we use these two properties in addition? Yep, everybody in here has graduated first grade. Yeah, you know this. All multiplication is adding a bunch of stuff in groups. So if you're adding it in groups or you're just adding it, it doesn't really matter. These are going to work no matter what. That's like 1 plus 3 is 4 and 3 plus 1 is not going to be 12, right? It's going to be 4. Doesn't matter what order the pieces go in. Multiplication just always works like that. Now let's talk about identity property, because identity property is ridiculously, insanely easy, and distributive property is a little, I would not say hard, I would say awkward. Awkward enough I may move the camera over so they get a little better view. Identity property is this. Multiplication is all about groups, right? Yeah?
Yes.
We're taking some number of groups to get how many we have all together. So I have 3 groups of 7 or 7 groups of 3, doesn't really matter. But we're all talking about groups. Now, this is so ridiculously easy. You're all going to look at me like I'm insane for even giving this a name. But in order for multiplication to work, we have to know that 1 times anything stays the same. In order for multiplication to work, we have to know if I take 1 times 3, it's always going to be 3. If I take 1 times 347,942, it's always going to be that number. Taking 1 and multiplying it by something never changes that number. That's why it's called identity. That number's identity never changes, right? It just stays exactly the same. Now, why do we need to know this? Well, if we're going to take 2 groups, and that's going to be the same number twice, if the same number didn't work with 1, if it changed with 1, it would change even more with 2, and then even more with 3, and then way more with 4, and by the time we got to 5, nobody would know what we were doing. But if 1 times that number just stays the same every time, every group stays the same, multiplication works, and math students are happy and not crying under their desks because they don't understand what's going on anymore. Now are you with me? It seems a little crazy that we even have to give this a name because it just is what normal life is. This is not a property we're going to talk about all the time, but it's a property, if it didn't work, nothing in math would work ever. The whole thing would be broken. Makes sense?
Yeah.
Looking back at our associative property, should we put any words up here? What if I put like 3 words up here? That might make it easier. Or 2. Let's go 3. With the associative property, groups can change. I was just looking at that thinking, it's pretty easy, but I don't have any words. With your associative property, groups can change. Okay, so we're going to aim this at the distributive property and probably cut off my face. Nope, just most of it. The distributive property. Multiplication can be broken into groups. Now, if you're on YouTube, they're busy writing. If you're on YouTube and this property doesn't make sense, look in my feed for the video called Diagramming the Distributive Property, and it will help a lot if this gets confusing with the numbers. Hopefully, it'll help a lot. I'm going to give you a simple math problem, multiplication. 25 times 6. You don't have to solve this math problem. I'll do it for you. I'll make Siri do it. What's 25 times 6?
The answer is 150.
150. Now, if these groups can change, it doesn't really affect how the problem comes together at the end. Do you think I could break these numbers up separately? Do you think I could change this 6 into 2 3s and take 25 times 3 plus 25 times 3 and still get 150?
Yes.
Yes. I need some parentheses to do it. It's going to look a little fancy. $25, 50, 75. 25, 50, 75. 75 plus 75 is 150, right?
Yep.
The distributive property means if this isn't working out for us, if we need more details, we can break this apart into some different pieces, and as long as the pieces all add up to the original problem, we're good. It didn't change the math any. Do you want me to show you one that is a little more likely that you'll be using? What if we broke 25 up by place values, right? We've been doing expanded notation where we break a number up by place values. What if we said, or 20 times 6 and then 5 times 6. I just basically did an expanded notation problem, right? Do you think that will work?
Yes.
Thumbs up if yes, thumbs down if no. Everybody's like, you wouldn't be putting it on YouTube unless you knew it was going to work already. And that is correct. Yeah. We've got a 20 and we've got a 5, right?
Yeah.
25. Our original problem has a 6 in it, right? We took the 20 times 6. We took the 5 times 6. It should work. What's 20 times 6?
It's 120.
All right, that gets us most of the way there. 120. We don't even need Siri for that. It's 5 times 6.
30.
30. What's 120 plus 30? 150. It doesn't even really matter what groups we break this up into. As long as we've got a group that equals 25 and we take those pieces all times 6 and we add them all back together, we're always going to get to 150. Do you know what the word distribute means? You're getting warm. Yeah, it means to pass out the pieces, right? If it's your birthday and you're getting cupcakes this afternoon, you're going to distribute cupcakes around the classroom, right? If I'm passing out papers, I'm distributing papers to my students. So if distribute means pass out, basically this means if I've got a group of 25, I can pass out those pieces, and as long as I multiply all those pieces by 6, I'm good. They'll all add up. It's all even. Feeling okay?
Yeah.
Cool.